Hello everybody, my name is Manuel Peuster from Paderborn University, and I will tell you something about the SONATA SDK. So during this presentation we will take a slightly different standpoint than we had during the other presentations. Now we will really focus on developing network services, testing network services, and afterwards deploying these network services we just created on our service platforms. So you have seen this figure in different presentations already. We focus on the DevOps approach. We want to apply the DevOps methodology to service creation and service deployment. And so far, we of course have service platforms for it. We presented the SONATA service platform. There are also other providers who provide you a service platform. But what is kind of completely missing at the moment is the support for developers to really create such network services. And this is where our SONATA SDK focuses on, and this is where we developed a couple of tools for. So this is basically the workflow we envision for a network service developer, and it is basically showing different kinds of tools we have already available. We have them as open source tools to be downloaded, and as Michael already stated, we designed them to be command line tools, so you can directly integrate them, connect them to a CI/CD Toolchain, for example. You can connect them to Jenkins to automatically package your services. Let me explain how a network service developer using SONATA would create his service. He, of course, will first start with creating a service project. A service project is something like you know already from integrated development environments like Eclipse. You create your project, you give it a name, things like this. You basically configure your workspace. Afterwards, you might want to reuse things. For example, you want to download an existing network function you want to use inside your service. So, of course, you don't want to reinvent the wheel, so reusing is a very important part of this workflow. At this point, our catalog system comes into play, where you can download service descriptors or function descriptors, which you then can reference from your own developments. Then you have this kind of manual step in the middle. This is really where you sit down, open an editor, and then you play around with your descriptors, you type in your descriptors, you modify maybe existing descriptors. Having this in place and defined your service as such, you want to package it. Let's go back. You want to package it, which basically means in SONATA we have one main artifact, which is our service package, which is created at the end of your development cycle and which can then be used to either be deployed to a service platform or to a local test environment, which we call the SONATA Emulator, which I will focus on later on in more detail. Doing this deployment of the service package isn't a manual, it's not a completely manual task. We also provide you with a tool for this, which is called the zone push tool. It's a command line tool where you can basically specify, please push this application to that service platform and run it. And at the end, we have analysis tools and monitoring tools which help you to debug your services. The important point here is that all this happens in the order of seconds. So really imagine you sit down and you want to implement a software. What happens? You type in your code, you press a play button, you check the changes, you check if your software does what it should do, and then you return to your editor and again do some changes. And this is exactly how our workflow works for network services. One point is that we have this kind of fork here in our workflow. And this is because we, on the one hand, provide a local test environment where you can deploy your service, and on the other hand, we provide the service platform. So this would be the arrow where you really push your service into production, upload it to a real service platform, and run it. And to apply this and to enable the DevOps methodology, we have for both of these branches basically a feedback loop. So monitoring data generated on the one hand in this local test environment, or on the other hand, in the service platform, is directly feed back to the developer so that the developer gets direct insights about how does the service behave, is there a need to do changes. And this basically closes then this development loop. So let me dig a bit deeper into our artifacts we have in our workflow, starting with our descriptors. As we already mentioned, they are somehow aligned to the etc descriptors. They are YAML based, and we did some minor modifications. For example, one thing we introduced is that we did the references between, for example, a network service descriptor and a network function descriptor in a way that it's really human readable, because having UUIDs or something similar there isn't really helpful. A human being has no understanding what's behind it. And having this list of vendor name and version combination available, you can easily say, okay, I want to use the network function from NEC with the name X and version 2 in my network service. And if you want to change it, you just have to replace this vendor name and version part, and you can include another network function. In general, our descriptors are always split into two parts or into two files. You have your main network service descriptor, which basically tells you which network functions to use, how are they interconnected, how does the forwarding graph look like, and on the other hand, you have got your virtualized network function descriptors, which basically describe which virtual machine image to use, how many resources to allocate, for example, how many virtual CPU cores to allocate there. And they are, again, interlinked with our referencing scheme based on vendor name and version lists. So having this in place, we are able to describe a service. We can edit these YAML files, write down what we want to have. Now we need to deliver it to our service platform. Therefore, we have our packages, where our packages are basically standard package formats. They are described by a package descriptor, which is not done by the developer. It is automatically generated. So we have a tool called SONPackage. And what you do, you type in SONPackage, define your project on your hard disk, then you press enter, and SONPackage will do all the magic for you to create such a service package. It also resolves automatically references you put into your descriptor. So if you say, I want to reuse a network function which is available in a catalog somewhere available on the internet, at this point, our workflow will automatically download this network function and include it inside this package. So at the end, you really have a single item you can send, you can download, you can use, which is kind of an application for a mobile phone. However, there are two kinds of packages we can have. There can be slim packages and fat packages. The only difference is if you include artifacts like your virtual machine images into the package or not. You can imagine uploading a virtual machine image may take pretty long if you have a bad internet connection. So it may be better to have a slim package which just includes download positions where you can fetch the virtual machine images from when the service platform wants to instantiate them. So we have our package available. We want to use it now, and we want to deploy it. We can, on the one hand, deploy it, as I said, on the service platform, and on the other hand, on our emulation environment. And this is done with a tool called SONPush. So again, you have a command line tool. You type in, please deploy my freshly generated package to service platform running at, for example, NEC or at Atos. Then you press enter, and then all the uploading magic is done. When this procedure has finished, you can again use the SONPush tool to say finally, okay, now the package is uploaded, please instantiate it, which would kick off the process in the service platform of really starting your VNFs and deploying the service. Now let us focus not on the service platform and the deployment for production, but let us focus on our most complex part of our SDK, which is our SONATA emulator. The SONATA emulator as such is basically a sandbox system which allows you to execute your network services locally on your laptop and do functional tests with them. So for example, you want to deploy a service locally and check if your forwarding chain works by sending some packets through them. Of course, if you do these local deployments, you are not able to check the performance of the service. This is something you can only do in the production environment. But to do functional tests and to find out if your update really works, for example, if your firewall behaves like intended and if it blocks the correct traffic, this is already enough. And this is the most important point in which a developer is interested at this stage of the development. So we created this emulation platform, and often people ask what do you emulate? Where does your emulation platform fit in? And it is basically, when you map it to Etsy, it is here. So we try to emulate on a local laptop the NFVI and the VIM part of the Etsy architecture, which allows us to put a Mano system on top of it. The Mano system controls our emulator, and the emulator then provides an execution environment for the services. It is pretty much like the workflow when you think of mobile application development, where you also have got your Android emulator or your iOS emulator on your local machine, where you can, of course, run your application, but you don't have things like accelerometers or things like this, or you don't have a GPS signal available. So you don't have everything there, but it's just enough to execute it and test your application. And this is exactly what our emulation tool does. So how does it look like? The tool as such is based on ContainerNet, which is an extension to Mininet, which is maybe known by some of you. And you basically start with defining a topology. So we are able to emulate multi-POP environments with arbitrary topologies. This is done in a Python file. You execute this file, and this starts up our emulation environment. In this example, we want to emulate two POPs, which are somehow interconnected. We can have a switch in between, and we can define, for example, our delays we want to have between our POPs. So from a bird's eye view, this is really our multi-POP environment with different data centers we want to use. Having this started and executed on your laptop, you can now again use our service package previously created, which is somehow lying around on your hard disk, and use our zone push tool to push this to the emulator and to finally instantiate the service. At this point in time, what our emulation platform will do, it will start the service, normally in form of Docker containers. So it will automatically deploy and configure our network service chain. And it additionally also deploys so-called service access points, which are basically additional containers which you can use to generate traffic, which is then sent through the service. After starting up the VNFs, our emulation tool talks to the POPs and to the switches in the network and does really a chain set up to forward the traffic in the correct way, like it was previously specified in the network service descriptor included in the Sonata service package. So up to this point, the process is completely automated. You basically press a single button and you have this running on your machine. And what you can do then, you can interact with your service. So you as a developer can go to the command line and basically type in commands. You can, for example, say the name of your virtualized firewall followed by a command ifconfig if you want. And what happens then, this command is directly forwarded and you can directly manipulate your network functions. You can change configuration files while the service is running, and you can, of course, monitor it by checking log files, things like this. So you can really work on your running service locally, play around with it, configure it. And this, of course, speeds up the development process because you don't have always to wait until your cloud testbed is ready, until your service is deployed in the cloud testbed, until you have logged in there. You can really do this locally and play around with this service. Okay, so having this emulator feature in place, we basically have here all its features. Again, I guess I explained all of them. So it's a multi-POP emulation platform, which allows you, and this is maybe one very interesting point, when you start up the emulation, we basically expose a Mano API endpoint to the outside. So whenever you start up an emulated POP, there is an interface created, for example, an OpenStack-like interface or a Sonata Gatekeeper-like interface to the outside to which you as a developer can connect. This means if you consider this to be a POP with a VIM, you can basically put any Mano system on top of this tool as long as you provide the correct API implementations, which is a pluggable system inside this tool. So it's not only to test your network services, of course this is a main use case, but also a tool which you might want to use if you are a Mano framework developer to test your Mano frameworks. And this is kind of an interesting approach. So having our service executed, we want to debug it. Decide of playing around with it, configuring it, logging into the virtual network functions and checking their log files. We provide a debugging and monitoring framework, which is basically monitoring all the links we have in our emulated service, and which allows you to quickly identify based on a graphical dashboard where you, for example, encounter packet loss. Typical example, when you write down your network service descriptor, you did a typo in your forwarding graph. This means at a certain point in your chain, all packets are lost, and you want to find out where this happens. And this can be done really easy with this tool. You just have a quick look at the graphical user interface, at this dashboard, and you directly see which interface see which packages, and you can find the bug and correct it and redeploy the service to check if it's working now. Okay, this is basically the end of the presentation. One important point about this emulation tool and this SDK, we already mentioned it's all on GitHub, so you can download it, check it out, and this is this is quite fun to play around with it, because often you have in these kind of projects, they provide full-blown nano systems, but if you want to download them, if you want to try them out, you need an open stack somewhere to connect them to play around with them. If you go this way and download the SONATA SDK together with the emulator, you just need a Linux laptop, and you basically can boot this emulation environment as a virtual machine on your laptop, run the SDK, and in a playground deploy services on it. And to make this process even more easier, we also provide you with example services. So on our GitHub account, there is a repository where we have several example services, for example, an intrusion detection system, firewall services, which you can simply check out from GitHub, use our packaging tool to generate the package out of these predefined projects, and then you can directly upload them to the emulator and see what happens. So testing this and playing around with it is really easy, and you should really, really give it a try. Thank you. Questions? Yes, please. Yeah, please. Mm-hmm.
Is there a micro? So I have two questions. First of all, you mentioned that when you develop a service and you want to use a VNF that is available in the catalog, it is downloaded and packaged with the rest. I understand that this kind of static linking. So can you motivate this? Why you use static linking rather than dynamic linking?
I think if you use this methodology, or this terminology, we have both. As I explained, we have fat packages and slim packages. A fat package would be kind of static linking, so you include your artifacts, all your artifacts in the package. If you use these slim packages, you can really say in your network service descriptor, please use the VNF coming from another point somewhere in the internet, maybe on GitHub, whatever. And then a service platform, of course, has to resolve this reference and has to download it at the time when it should be instantiated. But from our technical viewpoint, we would support both of them. You have basically two options to use the system.
All right, okay, thank you. The other question I have is, what support is there for SLA assurance related things? So delay requirements, perhaps during the development, giving indications how much the delay will be, etc. And then I'm mainly thinking about the descriptor files in YAML.
Yeah, you are right. This is something, or you would expect to have something like SLAs somehow defined in your descriptors, maybe in the existing descriptors. Maybe there's an additional file needed in the package. We don't have a final specification or something for it. We will definitely look into it in the second half of the project. in general, our packaging system is kind of very flexible. So we are pretty sure that there might be other artifacts like an, let's call it SLA descriptor, which might be needed at some point in time and which can then be, of course, included into the packages. But at the moment, in this version you find on GitHub, it's not included. It's something for the upcoming period.
Thank you very much.
I have one question, because almost everyone have mentioned that Sonata supports the Microsoft services based and it could be deployed in the container or Docker you mentioned. So I just wonder, is that you also support to deploy the VMF in Docker?
Currently, as we have seen today, we have our service platform using OpenStack, which are of course full-blown virtual machines. Our emulator uses Docker containers at the moment. This kind of already shows that we have both in mind. Of course, not everything is implemented everywhere. On the one hand, we are thinking of adding virtual machine support to the emulator, which is kind of a bit problematic because on a normal laptop it's hard to run many virtual machines. On the other hand, we can of course also think about adding container support to the service platform. We have this plug-in mechanism, so if someone comes along and provides us with a driver, so a plug-in, a wrapper, so to say, for a Docker VIM, we would be able to support it. But this is not implemented yet. However, we are looking into these things and it's not decided what will really be implemented.
So you mean the mechanism is there, you have plug-in capability. So if later, for example, OpenStack to support the Docker, release, and you can add the plugin and support this VM with Docker capability.
Exactly.
Yeah.
This makes things even easier. If OpenStack supports Docker, they kind of do the work for us because we support OpenStack. And this would make things easy. However, I'm not sure how far this OpenStack Docker integration is at the moment, but if it's there at some point in time, it should be extremely simple for us to adapt it because they will do the work for us.
Okay, thank you.